Loop equation. Recall. A loop is a closed path in a circuit. For example, this path is a closed path. Okay. A mesh is a loop path with no other loops inside it. Of course, I have an example. If we consider this circuit, maybe you can told me that in the circuit I have 3 loops. But pay attention, it's totally wrong. Because in the circuit I have this loop and this loop, this loop, 4, 5, and 6 loops. Pay attention. But it's true that I have only 3 meshes because as you can see here, mesh is a loop with no other loops inside it. And now it's time for loop equation. Consider this point. Here I have 2 paths. This is my point A, and to go from A to A, I have 2 paths, VA minus VA, to go from A to A. But here I have the same potential, so equals 0. So here I have this path or the other path. I can choose this path. So to go from A to A, here we enter from the negative terminal. So minus E. First I have minus E, tac, and here I use here Ohm's law. So here the sense of my current is like that, the same sense. So I have plus R1I. Same thing for R, so plus Ri. And all this thing equals 0. Therefore, E equals R1 plus R times I, which implies that my current I equals E over R1 plus R. Here, this is Pouillet's law for circuits. Pouillet's law. Pouillet's law for circuits. I have for you an example. E1, E2, I have this resistor with a resistance R1 and here R2. I consider my current I like that, and I can use directly Pouillet's law if I want the expression of my current I. Here, as you can see, my current I is from the positive terminal of my E1. So I have here plus E1. 1. And here my current, I enter here and I have here plus. But as you can see, my current is like that. So my current is outgoing from this negative terminal, okay, of my E2. So I have here minus E2 over the sum of my resistances, which mean R1 plus R2. I can also use loop equation if I want. Consider this point. I can choose this path, okay, to go from A to A. So the potential VA minus the potential VA, which equals 0, equals. So here, for this path, we enter from this negative terminal, which means I have here minus E1 plus E2. Here I have this current is like that, so I have plus R1I plus R2I. That implies my I, here I times R1 plus R2 equals E1 minus E2. Therefore, I equals E1 minus E2 over R1 plus R2.